day to all. Students, we are discussing about the chapter current electricity. We have already discussed about current, drift velocity, the relation between the two, Ohm's law in macroscopic form, resistance, color coding of resistance, carbon resistor, the temperature dependence, of resistance and resistivity, conductivity, heating effect, power, Kirchhoff's laws and its application, and meter bridge. We have already discussed in this chapter all these topics. Now, today we will discuss about potentiometer. What is a potentiometer and why this and where this apparatus is used? So let's discuss about the potentiometer. Potentiometer, it is a device which is used to find out EMF of the cell. We have already discussed the terminal potential difference and the EMF, cell, internal resistance of the cell, everything we have already discussed. So this potentiometer, it is used to find out EMF of the cell. The simple voltmeter that can't be used for finding EMF, electromotive force EMF, it is electromotive force. That is the maximum potential difference across terminals of cell in open circuit. Open circuit means when no current is drawn from the cell. That is EMF of the cell. By simply connecting voltmeter with the terminals of a cell, this is positive terminal, this is representing negative. So by simply connecting voltmeter, the reading of the voltmeter will never give us the EMF of the cell, because this voltmeter, it may not be ideal, practically it may have some finite resistance. Otherwise, the ideal voltmeter must have infinite resistance. So this voltmeter can't give us the accurate value of EMF of the cell. To find EMF of the cell, we use potentiometer. This potentiometer also used in finding the internal resistance of the cell. We will discuss one by one. First of all, today we will discuss only about the principle of the potentiometer, and we will practically find out how the potential difference across a given length is directly proportional to the length of 0 started from this side and 100 on this side. And there are two terminals across which we have to connect different apparatus. We will do that. So this potentiometer is simply a resistance wire. So now let's understand what is the principle of potentiometer. The principle of potentiometer is if constant current flows through potentiometer wire, then potential difference across 2 points is directly proportional to the length of the wire. So the condition is constant current. Constant current must flow through this potentiometer wire. Only then this V, the potential difference across 2 points, is directly proportional to length of that particular wire. Now let's understand what this state and how we will explain this, the principle. According to this equation, we can write that V by L is equal to some constant, and that constant, it is represented by small k and is known as potential gradient. We can say for constant current, potential gradient is constant for the potentiometer. Suppose now this is your potentiometer wire, 400 centimeter, fixed on the wooden box. This is terminal A, this is terminal B. These are thick strips, metallic strips, which are meant for connection. So 0, this will be 100 centimeter, 101, 200, 201, 300 and 301 and 400. So total length of the wire, it is 400. Now first of all, because the condition is constant current must flow through this potentiometer wire. So for that, what we will do? We will connect a battery of EMF E. The positive of this battery is connected to the terminal A and negative of this battery is connected to the emitter. Emitter is a device which can measure the current. Since it is negative terminal, the connection, so negative of the emitter should be connected with the negative. Positive, it is connected with the rheostat as variable resistance. So this is the circuit which is providing constant current through this potentiometer wire. In this current circuit, what we have connected? A battery of EMF E, emitter to check whether the constant current is flowing through the circuit or not, and this is a rheostat. Let's the resistance of this rheostat is capital R. Now since this wire, it is also EMF E is connected. Therefore, current in the circuit, it is EMF divided by R plus R dash. This is the current which is flowing through this circuit. Now, we have to keep a watch on this reading, emitter reading, so that the reading of this emitter, it should be constant, because if there is a variation because of temperature in the resistance, current may vary, and that can be adjusted with the help of a rheostat. So the reading of emitter, it should be constant. So for time being, I am assuming that there is no heating, so resistance is not changing. Resistance of the wire is constant, so the resistance is R dash, and the resistance of the rheostat is R. So total resistance is this. Therefore, current through the wire is EMF divided by R plus R dash. Now, what will be the potential difference across AB? We will find out potential difference across AB. That means across the end of the wires. It is the total current flowing through the wire multiplied by the resistance of the wire. Current is constant. R dash, the resistance of the wire, is constant. Why I am assuming this as constant? Because the resistance R dash, resistance, any resistance, it is equal to resistivity length upon area. So area of cross section of this wire is uniform. Material is constant. If length is constant, so resistance must be constant. So therefore, R dash is taken to be constant, and I am assuming there is no change in temperature. So there is no variation in the resistance of the wire, and it is R dash. So what will be the potential difference? It will be I into R dash. So I we have kept constant by adjusting this rheostat, taking the reading of emitter. R dash is the resistance of this potentiometer wire, that is constant. That means for constant current, VAB will be constant. If VAB is constant, the potential gradient, which I already defined, it is potential difference divided by total length. In this potentiometer, we have taken the length as 400 centimeter. So that means VAB by L, it is also constant. So potential gradient is constant for constant current. I hope you understand this concept, because this is the main thing in the potentiometer. Potentiometer works only when the constant current flows through the potentiometer wire. This I will show you practically now. How this VAB by L is constant, how the potential gradient is constant. We can take the reading and we can show you that this value, if current is constant, then the potential gradient, it will always be constant for a given constant value of current. So let's do the practical related to this. Let's connect. I will introduce the apparatus which is required, which I have already connected. I have drawn on the board. So this is your main circuit. This circuit is known as main circuit or primary circuit, you can say, or auxiliary circuit. What is the function of this circuit? This circuit is providing constant current we will find out the reading of the voltmeter divided by the length where the jockey is placed from a terminal. So that will give us the value of potential gradient. So let's do this practically. Now I have already shown you, this is your potentiometer, the 400 centimeter long wire. These are the two terminals A and B. Now let's connect these terminals with the, first of all we will connect with the battery eliminator. Battery eliminator, this is our battery eliminator. It is connected with the main supply. These are the wires. These wires are already cleaned, the edges are clean, so that there is no resistance offered by these wires. These are connecting wires. We will connect the positive of the battery eliminator with one terminal, and that terminal is called as A terminal as per the circuit drawn on the board. Connections should be very tight. If there is any loose screw, please tighten it. And we will connect the positive of the battery with this terminal, and then negative of the battery, it is connected with ammeter. This is ammeter. Ammeter, it is a device which is used to measure the current. So negative of battery eliminator is connected to the negative of the ammeter. Then another wire that will connect positive of the ammeter with the rheostat. This is rheostat. The rheostat, it can be used as variable resistance. It can be used as potential dividing arrangement. There are three terminals, 1, 2 and 3. When we use as the variable resistance, we use these two terminals, the upper terminal which is connected across the movable knob, and there is one fixed terminal. So we will connect this as a variable resistor, so that in case if there is change in the ammeter reading, we can adjust rheostat, the variable resistor, so that current can be kept constant. So I have connected positive of the ammeter with the lower terminal of the rheostat, then the movable terminal of rheostat, it is connected with the second terminal of potentiometer, which we represent as B terminal in diagram, circuit diagram. So this is our circuit diagram for the main circuit or auxiliary circuit, and the function of this circuit is to provide constant current. Now let's see. I will switch on. It is not. I will switch on the key. Let me connect first of all. Yes, it is switched on now. So you can see the reading on the ammeter. The reading on ammeter, it can be seen. So we have to keep that reading constant. So let's say I have kept it constant at this point, the 5 division. Now I will explain you how to take the reading of the emitter. In case of emitter, there is a scale. First of all, we have to find out the least count of the scale. How to find out least count of the scale? Between 0 and the bigger division, which is after 10 division, small division, it is written on the scale, it is 0.25. So that means the least count is 0.25 divided by 10, that is 0.025 ampere. So I have kept the needle at 5. So what will be the reading? It will be least count multiplied by 5. So 0.025 multiplied by 5, that is 0.125 ampere is the current which is flowing through this potentiometer wire. Now let's see what is the potential gradient. What I have to see, that the reading of the current, it should be constant, right? So what I will do, I will connect positive of the voltmeter, which I have shown here. The positive of the voltmeter should be connected at the terminal where the positive of the battery is connected. So positive of the voltmeter, it is connected at the terminal where positive of the battery is connected. That means at point A. So I have, these wires are already cleaned by the sandpaper so that resistance may not be included or give accurate reading. Now the longest wire which I will use for making connection with the jockey, because jockey I have to move over the wire, so it must be long. Negative of the voltmeter, it is connected with this wire, and this is jockey. Jockey, it is used to make the connection. It is simply the metallic body and the edge is very sharp. This sharp edge, it is to be moved over this wire. And this jockey I have connected. The wire should be very long, because if wire will be long, it will be easy for us to move over from one end to the other end. This is the simple reason. Now the voltmeter is showing 0. It is showing 0, but the needle is little up. You can make, because there is certain error, you can make this error less by this screwdriver. Move the screwdriver so that needle of voltmeter, it must be on the 0 of the scale. So I have done that. Now first of all, let's check what is the potential, whether the potential voltmeter is giving reading or not. So I am touching. Now you can see the voltmeter. As I will move, I have touched this jockey close to the end A, right, and moving this jockey over the wire, and you can see the reading of the voltmeter is also increasing. It is increasing, mean the potential difference, it is directly proportional to length. We will find it out the value, but I am just showing you that with increase in length, the reading of the voltmeter, it is increasing. So this is how you can see. I am moving the wire, jockey over the wire, the reading of the voltmeter is increasing. Now what we have to do to find out the potential gradient? Now let's check whether the emitter reading is constant or not. Yes, it is constant. There is a little increase, so again I have to keep this. You have to check. That can be seen. have to do? We'll find out the reading of voltmeter at certain given length. So let's take the length as 30, 30. So let's keep the length, this jockey over the 30. So I have kept the reading of the voltmeter. It is 0.1 volt. It is 0.1 volt. A little more. No, it's 0.1. Yes, 0.1 volt. Now, if I'll keep it on 60, it is, you can see it is 0.2 volt. And at 90, when the jockey is kept at 90, so it is 0.3 volt, right? So that means at 30 it is 0.1 volt, at 60 it is 0.2 volt, at 90 it is 0.3 volt. So potential gradient, which is potential difference per unit length, it is 0.1 divided by 30. It will come out to be your value. Then for second reading, it is your 0.2 divided by 60. It will again come out to be 1 by 300. Then 0.3 upon 90. Again it will come out to be 1 by 300. So potential gradient is constant at constant current. The current, it should be constant. So the reading of the emitter, you can see it is 0.125 ampere. It is constant. So for whole the practical, for whole the during the conduct of this practical, we have to keep this current constant. Because this is the principle of potentiometer. When constant current is flowing, the potential gradient, it is constant. Potential difference across a given length of the wire, it is constant. I can write down the reading also. I will show you how you can write down, how you can make table for this. The principle, how to prove the principle. What you have to do, you have to make a table. And in this table, what you have to find out? The voltmeter reading. It is in volt. Length L. It is in centimeter. And potential gradient, which is K, which is V by L. V by L. The unit will be volt per centimeter here. You can convert in volt per meter, serial number. We have taken 3 readings. You may take 7 readings, 6 readings. It's up to you, because more will be the reading, the lesser will be the random error. So voltmeter reading, it was 0.1, length was 30, potential gradient, it is 0.1 divided by 30, which is 1 by 300. Volt per centimeter. Reading was 0.2, length was 60, 0.2 divided by 60, it is 1 by 300. 0.3, length 90, 0.3 by 90 is equal to 1 by 300 volt per centimeter. So that means the value of K is constant. You can draw a graph also. From the graph also you can find out the potential gradient. The graph we can draw between the potential difference in length and the graph will be like for given length 10, 20, 30, length in centimeter I am writing 40, 50, 60 and so on, 70 and so on. And here you can have, let's say 0.1, 0.2, 0.3 and so on. At 30 it is 0.1, at 60 it is 0.2, at 90 it is 0.3. So the slope of this graph is equal to potential gradient. So this is how you can find out the potential gradient, and it is very important because for all the applications of potentiometer the current should be kept constant, and when current is constant, potential difference it is always directly proportional to length. For today's lecture we have discussed only this potential gradient.